Today we're going to be talking about how to find vector and parametric equations of the line segment. And in this particular problem, we've been given the line segment that connects two coordinate points. One of the points is 0, -1, 1, and we'll call that coordinate point P. The other coordinate point is 1/2, 1/3, 1/4, and we're going to call that Q. Now, as a reminder, I've written the formula that we use to find the line segment. This is going to give us the vector equation of the line segment, which joins the tip of one vector, which we'll say is r sub 0, to the tip of the other vector, which we'll say is r sub 1. This formula is only going to give us a vector equation where the parameter t is defined between 0 and 1. So t has to be greater than or equal to 0 and less than or equal to 1 for this vector equation formula to be true. So what do we need to do? Well, we need to call our coordinate points r sub 0 and r sub 1. So we'll say r sub 0 is going to be 0, -1, 1. We've just turned it into vector form where the initial point of this vector is at the origin and the terminal point of the vector is at our coordinate point P, and we call that the vector r sub 0. We're going to say the vector r sub 1 that starts at the origin and goes out to the point Q is the vector 1/2, 1/3, 1/4. So now we have two vectors, r sub 0 and r sub 1. We just need to plug them into our formula for r of t. All we're going to do there is say r of t is equal to quantity 1 minus t. Here's where we plug in our vector r sub 0. So we'll say 0, -1, +1, plus we multiply r sub 1 by t. So we have this t out in front, and we multiply it by the vector r sub 1, 1/2, 1/3, 1/4, like this. Now we just need to simplify this, and simplifying is as easy as distributing this 1 minus t across each of our vector components 0, -1, and 1, and then distributing this t across our vector components 1/2, 1/3, and 1/4. So here's what that looks like. Multiplying 1 minus t by 0 is obviously just going to give us 0. Multiplying 1 minus t by a -1 just gives us a -1 plus t. This -1 changes the signs on both of these values here, so +1 becomes a -1, negative t becomes a positive t. And then 1 minus t multiplied by 1 is of course just 1 minus t. So we distributed that. Now we just need to distribute our t across this second vector. So we're going to get the vector here 1/2 t, 1/3 t, and then 1/4 t. And now, because we've essentially added two vectors together, we just have one vector added to another. We're just dealing with vector addition, and we can add each of our components together. So adding our x components together, 0 plus 1/2 t just gives us 1/2 t for our x component. For our y component, we want to add -1 plus t to 1/3 t. Well, we've got our -1 out in front, then we just get t plus 1/3 t. Think about this t here as 3/3t. So when we add it to 1/3 t, in our numerator, we're going to get 3 plus 1, or 4, and we have our common denominator of 3. So we're going to get 4/3 t. So -1 plus 4/3 t, like this. And then for our z component, 1 minus t plus 1/4 t. We've got our 1 hanging out in front here, and then we have here a minus 4/4t. -4/4 plus a positive 1/4 here is just going to give us a minus 3/4 t, like this. And keep in mind here, we should pull this down. T is defined as greater than or equal to 0 and less than or equal to 1. Now remember, we were asked to find vector and parametric equations of the line segment that joined these two coordinate points together. Well, this answer here is the vector equation that joins those 2 points. All we need are the parametric equations joining these 2 points together. So this is going to be the vector equation. Now we need parametric equations, and parametric equations are going to be really easy once we have the vector equation in this form, because all we're going to do is treat this first component as x, our second component as y, and our third component as z, and our parametric equations look like this. We get x is equal to 1/2 t, the x component of our vector equation that we already found. Y is equal to -1 plus 4/3 t, and z is equal to 1 minus 3/4 t, and these three together are the parametric equations of the line segment joining these two coordinate points. So that's how you find vector and parametric equations of a line segment.